Okay, so now somebody pointed out that I carelessly wrote a 0 there. That's something I've been nagging you about, so, you know, you do it, I penalize it, I do it, I look like an idiot now. So it's a 1. That, of course, gives me the right point. Okay, so where's negative 2/3? Well, here's 1, negative 1, and here's 1. Negative 2/3 is, well, you take the interval between 0 and negative 1 and split it into 3 equal parts as best you can. And right here is negative 2/3. And handy, very, very handily, we have negative 1/3 here. And then we can go ahead and put our 1/3 and 2/3 in the interval from 0 to 1. And it looks like all our x values are between here and here. So what's going to happen to this graph? It's going to get squashed in. Okay? It's not a vertical stretch, it's a squashing in. Okay? It might look like a vertical stretch, but it isn't. Okay? So, negative 2/3, 1/4. Well, 1/4, you know, it's about here. 1/2 is going to put you about here. 1 is going to put you here. And then at 1/3 you get 2. At 2/3 you get 4. So at 1/3 you're up to 2. And at 2/3 you're all the way up to 4. And you get a graph. It has the same basic shape, but it's squashed in this way. Okay? It's not vertically stretched. If it was vertically stretched by anything but a factor of 1, then this point wouldn't land at the same place it did for the original function, right? This would have to be vertically stretched, okay? So it's not a vertical stretch. It's being squashed in. We call this a horizontal compression. By factor 3. What's this mean? It means every point moves 3 times closer to the y-axis. Your point moves horizontally 3 times closer to the y-axis. Now, I'm not sure I did this. This looks like it moves, let's see, 1, 2, 3. Yeah, this one should be a little further out, but you get the idea. This point moves to here. This point moves to here. This point's on the y-axis. It doesn't have to move. This point moves to here. This point moves to here. Make sense? Okay. So I didn't do it with complete accuracy. This point looks like it's a little too far out. This point looks like it's a little too far in. So you get the idea, right? And I could have done a better job of that, and you can figure out how to do a better job of it. Okay? So this is another kind of transformation that we haven't talked about. We've talked about vertical stretches, vertical shifts, horizontal shifts. There's also horizontal compressions. Okay? And those are the 4 basic things you can do. There's also reflections, but I talk about them a little differently. Your book talks about them in the first chapter. Okay? So I'm going to, in general, f of 3x horizontally compresses the graph of f of x by factor 3. I didn't mention horizontal compression earlier because we didn't need it earlier. But now, if we want to talk about the general exponential function 2 to the kx, we have to talk about it, okay? So here's where it is. We've had plenty of time to get used to the other 3 transformations. This one should just kind of fit right into the big picture, okay? If not, get better transformations. Practice. Okay. So, well, let me state this in another video.